Hi guys, we're going to be looking at the interior angles of a polygon today. So let's crack on and get the job done. Those are the exterior angles of a polygon. They lie outside the polygon. And there's a separate video explaining exterior angles. Very briefly, the total of those exterior angles will be 360 degrees. But we can see the interior angles lie on the inside of the polygon. And I hope you can see clearly that each exterior angle and each yellow interior angle lie on a straight line. Therefore, an interior angle and an exterior angle must add up to 180 degrees. And that's our fact from this slide. An interior angle and an exterior angle add up to 180 degrees. It's an important fact, which is why it's in a yellow box at the top of the screen. We're now going to use this fact to answer this particular question. We have a look at the question. We are given some exterior angles, and then we are asked to find x, where x is an interior angle. Remember, exterior means outside, in this case of the polygon. Interior means inside the polygon. In order to find x, we need to find y, which is that angle there flashing for us. Y is an exterior angle, and from a previous fact, the sum of the exterior angles are 360 degrees. They all add up to 360 degrees. Therefore, if we add all the exterior angles together, that's y, 93, 58, 60 and 94. They add up to 360 degrees. That gives an equation y plus 305 equals 360, and therefore y will be 55 degrees. But we're not being asked to find y. Y is only a stepping stone in order to find x. And we're using the fact at the top of the screen there that an interior angle and an exterior angle add up to 180 degrees, which means y and x add up to 180 degrees. Well, we know what y is. It's 55 degrees. Therefore, from that, we can calculate x. We subtract 55 from 180, and that gives us 125 as our value for x. The next part of the lesson is looking at the sum of the interior angles, where sum means the total of them. We are familiar, probably, that the angles in a triangle add up to 180 degrees. If we have a quadrilateral, we can split the quadrilateral into two triangles. And when we do that, each triangle, the angles will add up to 180 degrees. So we have 180 degrees as the sum of the angles in the top triangle, and 180 degrees in the angles in the lower triangle. And we can see that the total of those angles are the total of the angles in the quadrilateral. Therefore, the sum of the angles in a quadrilateral is 360 degrees. We can extend a similar technique to shapes with more sides. On the left-hand side, we have a pentagon, and we can split the pentagon into three triangles. Each of the triangles will have a total of 180 degrees in their angles. Therefore, with three triangles, that will be 540 degrees. In the right-hand side, we can split the heptagon into five triangles. So the total of those angles will be 5 lots of 180 degrees. Altogether, that's 900 degrees in a heptagon. So let's look at what's going on here. We've managed to split each of the polygons into triangles. The quadrilateral has 4 sides and it splits into 2 triangles. The pentagon, 5 sides, splits into 3 triangles. The heptagon, 7 sides, splits into 5 triangles. There are always 2 fewer triangles than sides, and each triangle has 180 degrees of angle in it. So if our shape has n sides, there will be 2 fewer triangles. That's n subtract 2 triangles. And therefore the total of those angles is the number of triangles, n subtract 2, multiplied by 180 degrees. That's a really important result. That's why it's in a yellow box, that the sum, the total of the interior angles of a polygon is equal to n subtract 2 lots of 180, where n is the number of sides of the polygon. Here is a table of the different types of polygons, starting from the triangle up to a decagon. And if we look at the columns for the number of sides and compare it to the number of triangles that are formed when we split the polygon up, we can see that the number of triangles is always 2 fewer than the number of sides. Therefore, that gives us a total of the interior angles as the number of triangles in the polygon multiplied by 180 degrees, because there are 180 degrees in a triangle. Another way of working out this total is to say, well, I know that there are 180 degrees in a triangle, and every time I add a side, I'm adding another 180 degrees to the total. I really recommend that you learn this table, that you learn the names of the polygons, and you understand how to find the total of the interior angles, either in terms of n minus 2 lots of 180, or by starting at 180 degrees with a triangle and adding 180 degrees every time you increase the sides. So armed with this new fact that the sum of the interior angles is n subtract 2 lots of 180, where n is the number of sides, if my polygon has 8 sides, then if we subtract 2, that'll be 6 lots of triangles, that'll be 6 lots of 180 degrees, and that gives us a total of 1080 degrees. If our polygon has 16 sides, can we think how many triangles that will be? Take away 2, that'll be 14 triangles, so that's 14 lots of 180, and that's 2520 degrees, which is the total of the interior angles of a polygon with 16 sides. This example is in reverse, if you like. We are given the total of the interior angles. We want to know how many sides it has. Well, that total, 2160, has come from this formula whereby it's n subtract 2 lots of 180. So n subtract 2 in brackets times by 180 gives us the total 2160. If we divide both sides by 180, we end up with a value for n subtract 2. And it works out that n subtract 2 equals 12. In order to find n, we just add 2 to both sides, and we find that n is 14. And remember, it's n, that's the number of sides. So the number of sides of our polygon, whose sum of the interior angles is 2160 degrees, is 14 sides. Let's put everything we've learned together in a recap. Interior angles lie inside the polygon and form 180 degrees with the exterior angle. The total of the interior angle depends on the number of sides of the polygon. The greater the number of sides, the greater the total of the angles. But we have a formula for the total of the interior angles, which is n subtract 2 times 180, where n is the number of sides. And that's the job done.